I'm R. Prabha, Assistant Professor in the Department of EC, SNS College of Technology. In this video, we will see about magnetic field intensity and magnetic flux density for the unit magnetostatics. And magnetostatics, the scientist Oersted discovered the relation between electric and magnetic fields in 1820. He stated that when the charges are in motion, they are surrounded by a magnetic field. The charges are in motion constitute an electric current, thus the current carrying conductor is always surrounded by a magnetic field. If such a current is steady, that is time invariant, then the magnetic field produced is steady magnetic field. The direct current is steady flow of current, hence the magnetic field produced by a current carrying conductor is a DC current, that is static magnetic field. The study of a steady magnetic field existing in a given space produced due to the flow of direct current through a conductor is called magnetostatics. So there are three sources of magnetostatics. The magnetostatic field originates from either a constant current or permanent magnet or electric field changing linearly with respect to time. And now we are going to analyze the analogy between the electrostatic and magnetostatic fields for various parameters. First, considering the field. For electrostatic, the field is electric field E vector and displacement density vector D vector. And for magnetostatic, the magnetic field is H vector and the flux density is B vector. And the factor influencing the electrostatic field is permittivity epsilon, and for magnetostatics it is permeability mu. And related Maxwell's equations, del dot D vector is rho v, del cross E is equal to 0. For the case of magnetostatics, it is del dot B vector is equal to 0, del cross H vector is equal to J. The potential, electric scalar potential is E vector is equal to minus del V, and for the case of magnetic potential, B vector is given by del cross E. And energy density for electrostatics, it is WE is 1 by 2 epsilon E squared, and for magnetostatic the energy is Wm is equal to 1 by 2 mu H squared. And magnetic field and properties, for this case, considering a permanent magnet having two poles, north and south, the region around the magnet within which the influence of magnet can be experienced is called the magnetic field. So such a field is represented by imaginary lines around the magnet and is called as magnetic lines of force, and this will be introduced by Michael Faraday, and the direction of these lines is always from north to south, and these lines of force are also known as magnetic flux lines. Hence, every magnetic flux starting from north pole to south pole and complete the path from south to north internal to the magnet. So, always the magnetic flux lines forms the closed loop. So, this will be represented in the diagram. If we observe outer to the magnet, the magnetic force of line is from north to south, and internal to the magnet, this lines of force is from south to north. So, this complete a closed path. So, we can also find the magnetic field due to current carrying conductor. For this, considering a straight conductor having a direct current, so it produces a magnetic field around it along its length, and the lines of force will be in the form of concentric circle in the plane right angles to the conductor, and this is shown in the diagram. So we have a current carrying conductor, the current is the direct current I, conductor is in perpendicular direction. When the plane in the right angles to the conductor, we have a magnetic flux lines or magnetic lines of force, and this will be explained by a thumb rule. So according to the thumb rule, that is right hand thumb rule, if we take a current carrying conductor in the right hand such that the thumb is pointing in the direction of current and parallel to the conductor. So now the direction of magnetic flux around it is the curved finger pointing the direction, and the magnetic lines of force is magnetic flux lines always form a closed loop and exist in the form of concentric circle around a current carrying conductor, and this flux lines is denoted by the letter phi, and it is measured in Webers. 1 Weber is 10 power 8 lines of force, and magnetic field intensity represents the quantitative measure of strongness or weakness of the magnetic field, and it is denoted by H, measured by Webers, and also measured by Newton per Weber or amperes per meter or amperes turns per meter, and it is a vector quantity similar to electric field E vector in electrostatics. And magnetic flux density we have seen already, it is denoted by phi, measured per Weber per square meter, also measured by the unit Tesla, and this is similar to electric flux density D in electrostatics. So now there is an important relationship in magnetostatics, the relation between the magnetic flux density B and magnetic field intensity H is B is equal to mu H, and this mu is given by mu naught mu r, and this mu naught is equal to 4 pi into 10 power minus 7, and mu r is equal to 1 for the medium is air. So now the assessment question, the sources of magnetic field, we have seen the 3 sources. The magnetic lines of forces also we have seen, that is the flux lines. The relationship between magnetic flux density and field intensity is B is equal to mu H, and also we have know the right hand thumb rule for determining the magnetic field direction around a current carrying conductor having DC current. So thank you.